All right, today we're going to talk a lot about what's called inverses. All right, we're going to try and find some inverses of functions. All right, so we're going to find our function inverses. And so to start, all right, and in your books, this is 5, 6 if you're looking in your books. To start, let's just take a real simple function. We'll say f of x, and we're going to say f of x is equal to 2x plus 3. Um, and so if you think about the word inverse, right, we're going to try and find the inverse of a function. We're going to kind of reverse everything, or we're going to undo everything. So we're going to write this, I'm just going to write this as y equals 2x plus 3. It's still our same function. And our goal here is we want to get it so x is by itself. Now we're still going to have y over here, but let's start just like you would normally. Pretend y was a number for a second. And let's do everything to get x by itself. So the first thing I would do is subtract 3 from both sides. And that would give me y minus 3 equals 2x. And then we would divide by 2. Okay, so we're left with y minus 3 over 2 equals x. You say, all right, Mr. Jones, great. You're just doing a little bit of algebra, fancy algebra there. What does this really do for us? What this does is, let's say we know that our output, or our y value, our output in this case, let's say our output was -7. And we want to know, hey, what was the input, or what was the x value that goes with that output? Well, we could just plug -7. Our output is typically our y value. So let's plug that in wherever we see y. -7 minus 3. And that will give us our input, or our x is our normal, our input. So we're going to go backwards and we're going to find our input. -7 minus 3 would be -10. -10 over 2. So our input would be -5. So this means if we had gone back to our original equation, we could kind of check this. If we had plugged in -5, we should have gotten our output should have been -7. And I think you would see that this is true. 2 times -5 plus 3, well, that's -10 plus 3, which is indeed -7. Okay, so we're just kind of, again, we're just working backwards, and we got x by itself. We got an equation where x was by itself, and that's actually going to turn out to be what's called our inverse function. Okay, so let's do one more example. Let's do another example with some of this. And let's say this time our function is 3x minus 1. So again, to start, we're just going to call this y equals 3x minus 1. And we're going to start to undo this equation over here on the right so we can get x by itself. So y plus 1 equals 3x, and divide both sides by 3. Okay, so our inverse function, all right, we have this y plus 1 over 3 equals x. Okay, so we got x by itself. And the last step, we're actually just going to flip our x and our y. We're going to make them switch places. So our inverse function is x plus 1, right? We're just switching the x and the y. This would be our inverse function here. Okay. You might not see this in your book, but if you ever see this on an SAT, if they say, hey, f to the -1 of x, what this really means, this is your inverse function. Okay, that's what they're saying. If they say f to the -1st, it doesn't mean to the -1st power. That's just how mathematicians normally say this is the inverse function. Okay, and it turns out, there's actually a really cool property of functions and their inverses. So let's take a look at that for a minute. So remember our original function, if we went back up, was 3x minus 1. That was our original. And our inverse function, remember that -1 just means our inverse function, was x plus 1 over 3. All right, so there's our two functions here. Now we're actually going to graph this a little bit, and we're going to see actually a cool property that comes out of this. And so our first function, our original, would have an intercept of -1, and it would have a slope of 3. So it looks something like that. Okay, and it would keep going on forever, obviously. Our inverse function, another way we could have written this, is 1/3 x plus 1/3. I'm just dividing both of these terms by 3. And so that would be a function with a y-intercept of 3 and a slope of 1/3. Okay, or goes up 1 over 3 every time. So we go up 1 over 3, and so we could start to connect the dots that way. It turns out, and I didn't draw my picture super accurately here, these, every time you take a function and its inverse, they have a really cool property in that if you were to graph this over the line y equals, oh wait, I drew my blue graph wrong, that would be y. It's y. Should have an intercept of 1/3, so it'll look something, go back to my pen, it'll be down here. Okay, this would be our inverse function here. I apologize. There's actually a really cool feature in that if you take a function and you reflect it over the line y equals x, all right, just this 40 diagonal on the 45-degree angle, the line y equals x, if you reflect it over this line, so if you take it and you flip it over this line, you're going to get your inverse function. Okay, they should be mirror images, and if they intersect, they should intersect on this y equals x line. Okay, so we will do one more example of finding an inverse, and then we will call it good. So let's make our function a little trickier this time, and let's say that our function is 2x cubed plus 1, so f of x. And so we're going to try and find the inverse function. So, well, y equals 2x cubed plus 1. So again, we're trying to get x by itself, so we're going to undo everything. Again, you're working from the outside in, so since this 1 is the farthest thing removed, if you think about your order of operations, you're going backwards, our PEMDAS. We're going to work up the ladder. So we got to undo any addition and subtraction first, so that's why we're subtracting. Y equals 2x cubed, divide both sides by 2. Okay, so y minus 1 over 2 equals x cubed. And to undo something to the third power, we just need to take the cube root of both sides. So we're left with, all right, this cube root of y minus 1 over 2 equals x. And so to make it our inverse function, or again, the inverse function notated like this, our final step has to be flipping the x and the y. So this would be the cube root of x minus 1 divided by 2. Okay, so that's how you would find your inverse function, even if it's something a little more tricky than just a regular linear function. All right.